So we want to talk about interpretation of skeletal structure. Now, why is this topic important? Is because most of the structures you're going to be seeing will be represented like this. Now, this is what I refer to as skeletal structure, right? Skeletal structure simply represents a case where lines is used to represent bond, and each of these points is used to represent carbons. Now, in skeletal structures, you're not going to see hydrogens, but then hydrogen will be inside of it. So for you to be able to understand how to name skeletal structure, you must understand that these lines you're seeing here stand for bond. These points stands for carbon. So in order for us to understand better how skeletal structure can be interpreted, I gave us these 2 points. I said every end of line, intersection, or edge represents carbon. Now, what do I mean by end of line? This point is end of line, this is end of line, and this is end of line. So these 3 spots represent carbons. Now, intersection, obviously, where two or more lines intersect or meet, right? So this intersection or edge, this is also intersection. So if I want to interpret this guy, this carbon here is this one. This line is this. This spot is carbon. This line is this. This spot is carbon. Now, there's a line down. And this guy. So this compound has 4, or let's say how many 5 carbons. 1, 2, 3, 4, and 5. So basically I've interpreted, because I said every end of line, these points are end of lines. They are all carbons. Every intersections, this edge all represents carbon. Now these lines stand for bond. So I've done this. Now for me to know the number of hydrogens that these carbons will actually have, because here hydrogen is not showing. So for me to know the number of hydrogens that is present here, this is what I'll simply do. I'll say, to know the number of hydrogen on each carbon, I'll say 4 minus number of lines or bonds. Now, why did I say 4? Because carbon can hold maximum of how many bonds? 4 bonds. So if you look at this guy, so let's label this place A, B, C, D, and E. So this is carbon A, carbon B, carbon C, carbon D, and E. Now, carbon A is just having 1 line. This guy, this spot is carbon. Now, the number of lines attached to this guy is just 1. So for me to know the number of hydrogen that will be present on this carbon A, I'll say, since this carbon A can be seen to have just 1 line attached to it, I'll now say 4 minus 1 is how many? 3. So this guy will have how many hydrogen? 3 hydrogen. Carbon B, how many lines can we see is attached to carbon B? 2 lines. This and this is also. So for me to know the number of hydrogens here, I'll say 4 minus 2, right? So here becomes CH2. Carbon C has how many lines? 3 lines. 1, 2, and what? 3. 4 minus 3 is what? 1. So here would be CH. Carbon E has just 1 line. 4 minus 1 will give us what? And carbon D has just 1 line, is it also? So this becomes CH3. So this is actually how